All right, 5.4 point slope form part 2 is real short today, only 3 slides. So what is an equation for this line? Remember, we're working with point slope form, so it has to look like y minus y1 equals the slope times x minus x1. Okay, so the first thing we need to know is what is this slope? And if you remember, when you have a graph, you just have to count. So we're going to we'll draw our triangle and count it. So 1, 2, 3, 4, 5, 6, 7. So it's rise 7, run 1, 2, 3. There's our slope, 7/3. And then we just get to pick one of these ordered pairs. I'm going to use the positive one, and I'm going to plug that in as my x and my y. So I will have y minus the y value equals my slope times x minus the x value. Okay, if I wanted to use the other ordered pair, the one that had all the negative numbers, right here, I would have y minus -3 equals 7/3 times x minus -2. Those are your two options for answers. Okay, one more practice one. What is an equation in point slope form? So remember, point slope. I know I keep writing it, but this one's a hard one to remember sometimes. Y minus y1 equals the slope times x minus x1. All right, my slope, if I draw my triangle, is rise 3, run 1, 2, 3, 4, 5, 6, which really is just 1/2. And I, as usual, I'm going to choose the all positive one. So I'm going to say y minus 4 is equal to 1/2 times x minus 4. If you like negative numbers and you chose the other one right here, you would have y minus y equals the slope times x minus the x. Those are your two possible answers. All right, last one is a word problem, real life. What is an equation in slope-intercept form? Okay, remember that slope-intercept form, they're changing it up on you, is really y equals mx plus b. That was from 5.3. Okay, so we need an equation in slope-intercept form that gives the balloon's altitude at any given time. Well, we need a slope and we need a y-intercept, which means a starting point. Okay, so our slope, we're going to have to figure out what it's changing by every time. Okay, and on the y side, it looks like we're going down 50, but then down 100, and then down 50. Okay, let's check the x side. Looks like this went up 20, but the next one went up 40, and then again only up 20. So remember, when they're not the same, your slope has to be the y over the x. Okay, so if I checked all these out right here, I have -50 over 20. Okay, and then the second one is -100 over 40, and the third one is again that -50 over 20. So the same as the first one. Now we just need to make sure once we reduce them, we get -5 over 2, and this one is -10 over 4, which also reduces to -5 over 2. So we know that this is our slope because they all change by the same amount. So -5 over 2 is our slope. All right, then each one of these is an ordered pair. So I'm just going to pick that first one because I need to figure out what my y-intercept is somehow. All right, so I'm going to plug those in. My y value is 640. My slope is -5 over 2. My x value is 10, and I'm just looking to solve for b. Okay, so if I did -5 over 2 times 10, that's like 2.5 times 10. So I have 640 is equal to a -25 plus b. Then I have to add 25. So my y-intercept, or my starting point, is going to be 665 meters. All right, so my final equation, let's change the color so you can see the difference, is going to be y equals -5 over 2x plus 665. Okay, then the last thing is it wants to know, what do these represent? What is the slope and the y-intercept? Well, the slope is telling me that this balloon is going down, because of the negative, down by 5 meters every 2 seconds. Okay, this 665 for my y-intercept tells me that that's the altitude that it started at. All right, that should be the rest of this lesson. This is the full assignment that will be due tomorrow, page 316, numbers 8 through 23, number 27, number 30, and the 5.